I'm Jochen. I'm a professor at Cornell University. And as you very likely can hear, I have a strong German accent. I grew up in Germany, came to New York City as a postdoc. This means at the face to do some research. I originally planned to go back after 2 years, but the original years became now over 30 years. So I spent the last 35 years doing research in New York City.
My name's Lonny Levin. I have a more traditional path. I got my PhD at Cold Spring Harbor Laboratory, did a postdoc at Johns Hopkins in Baltimore, and then came here. And among my earliest works, I became friends with Jochen, and the two of us started to work on a project together. And that's what we're going to talk about today. After just about 5 years here or so, my 5th year or so, Jochen and I merged our laboratories into a single laboratory studying the target we're talking about today. And we've been working and running a single laboratory ever since. You ask about the primary motivation, and to be fair, we followed the science. We studied this, there was this problem in signal transduction, that there was this sort of activity missing in the study of this second messenger cyclic AMP. And Jochen and I together took on the challenge. And together we were able to sort of solve that problem. And in that work, it took us into the male contraception field. And what's driving us now to make a male contraceptive is the unmet need. One of the two shocking statistics that sort of drive me, at least personally, are that in the United States of America, about 45% of pregnancies are unintended. And the other is a more global perspective. The last real advance in male contraception was by the Romans. And I mean, 2,000 years ago, the Romans were using condoms, and that's been the last advance that's significantly moved the field. And so just like it was a challenge to understand this activity that Jochen and I took on that didn't sort of explain the world of second messenger signaling very well, this became a challenge. And we're really meeting the challenge that there's got to be an advance. After 2,000 years, something has to move.
What essentially happened was that we together characterized a new principle which is happening inside of cells. And when we went deeper, it was in a way a sort of surprise that what we had discovered was the switch which turns resting sperm on and lets them move. And when we got this, that we really found something which is so essential for male fertility, this is when we started to discuss male contraception.
If I had to summarize what I think was the barrier to a male contraceptive being developed in the past few decades, let's say, was the reluctance of scientists to appreciate that men were willing to take on the challenge, that men were interested, that men had a stake in family planning, and that men were willing to be participants in the family planning decisions. And I think that's a misnomer, a horrible misnomer. Since Jochen and I have worked on this, and since we've sort of had the idea that a male pill, a male birth control may be possible, almost everyone we mention it to, male and female, males more than anything else, their eyes widen. They immediately sort of, you can almost see them salivating. So the thirst for this is real. The thirst for some functional way of avoiding the condom and avoiding and participating in family planning is a huge, huge desire of the people. And I think the problem has always been that pharma was very reluctant to see that.
what I see as a problem is that the concepts which were there for male contraception were all based on interrupting the cycle of male hormones. And this would have side effects. And this would be, it would need weeks, months until the effect of these drugs would lead to that sperm is missing. What we are doing is a total different concept. We prevent normal sperm from being activated for a few hours. And 4-6 hours later, sperm is normal again.
Jumping off of what Jochen just mentioned, I completely agree with that. I missed that. I'm sorry I didn't offer that myself. The idea that all the previous thoughts were that men would have to take some agent, pill, gel, cream, do something for months, weeks to months, before anything would be, before there'd be any contraception. And so you'd have to really prepare far in advance. You'd have to be committed, and you'd have to be sort of compliant for a long period of time and remain compliant like that. And so the reluctance to take on this challenge, basically the ideas were to reduce the sperm number. And so to reduce the sperm number, you need a long time, because sperm take weeks to develop. And once they develop, they're sitting, waiting to be ejaculated. So in order to get the sperm number down, it takes all this time. And that's a huge commitment. The difference that we're working on is that I can decide to have sex an hour from now, and I can take a pill now, and in an hour from now, my sperm won't do a number of the things they're supposed to do to make an egg to fertilize the female. And if that works, that's a totally new paradigm. That's a paradigm that says I don't have to commit, I don't have to decide. All I have to commit to is having a pill in my pocket, which obviously men do with the condom. They go prepared, but it's not like they've been preparing themselves for weeks or months. And the other side of the coin is the reversibility. If I want to be infertile for the next 2 weeks, and then I decide that I want to be fertile after that, I don't take a pill next time in 2 weeks from now. And it's totally reversible. It's reversible. Our animal studies are reversed in a day. We presume that'll translate to the human. And so the paradigm we're attempting to develop affords a flexibility that no one thought of before. And with that flexibility comes, I think, a fantastic opportunity.
So where are we in the moment? Essentially, if we give one of the compounds which we are developing and have developed to a male mouse, and an hour later put this mouse together for 5 hours with a female, instead of having 50% pregnancies, we are way, way down. We are now around the range of 1 to 2%.
We have about 90% contraception, which is where a lot of barrier methods are in practice and things like that. And we're working to improve it. Mm-hmm. To be fair, that's one of the things that we greatly appreciate MCI funding for. MCI is giving us the support so that we can make our compounds better and make sure they work in human and get to that magic threshold where we think it's a viable product.
Or what are challenges I foresee? In the moment, we establish now that male contraception works in mice. but mice are not human. So, and we cannot directly jump to humans. So the next challenge we have is that we demonstrate male contraception in rabbits. Rabbits are nearer to humans in this case than mice. And then, of course, middle long term, we want to go into clinical trials where humans are involved, and this will show whether our principle works or not.
I have to say the biggest barrier is to us, the biggest barrier we have to overcome is that no one's ever thought of a contraceptive like this. So that's a double-edged sword. It's fantastic because we're first. It's fantastic because it's kind of cool. And like I said earlier, that when I tell people about this, their eyes light up because it's nothing that anyone's ever thought of. But it's tough because we have to make up new methods. And by make up new methods, it's not like make them up. It's we have to develop new methods. Jochen just mentioned a second ago that we have our efficacy in mice and it's working, but mice are not the best model. So humans have sex when they want to. So they would take a pill an hour before they're ready. We can't control when mice mate. So we put them in a cage, and we put them in a cage together with a female for 5 hours, and some of them do and some of them don't, and some of them do after an hour and some of them do after a longer period of time. So we can't actually control that mating window the way we anticipate it would be used in humans. It took us a while, and we've identified another animal. Jochen mentioned it earlier, rabbits, where rabbits are a lot easier to control the mating. This is sort of a joke, but when rabbits get put together, they immediately mate. And maybe that's one of the reasons why there's a joke that, you know, rabbits produce a lot of offspring. But it's actually perfect for us because then we can give a rabbit our compound, wait the hour, and then put it together with a female. And within the next 15 or 20 minutes, they've mated. So that alone is more like the human situation. And to be fair, we've been working on this for 2 or 3 years now, and we just started that now because nobody told us that our type of contraception needs a different model than the normal types of contraception, than the other methods people are attempting. They could do it in mice because they've treated mice for 6 weeks with some drug. The mice sperm number is down, and they can put them in a cage with a female mouse for 4 days and see whenever they actually mate. That's not our paradigm. And so we needed to develop new methods. And it was, look, someone else who's trying to develop an on-demand, we refer to this method as on-demand contraception. If someone else is trying to develop an on-demand contraception 4, 5, 6 years from now from a different target with a different method of, you know, inhibiting something different in the male, they would look at us and say, we're going to rabbits right away. So we're sort of we're generating a new path.
Look, essentially, we climb a new mountain which nobody climbed before.
Use the climb a new mountain thing. That's better than mine. We're asking about acceptability to men across different cultures. And the first thing to appreciate is that this is temporary. So I would tell any man about this method that it's a one-off. You take this pill, you're infertile, you have a normal ejaculation, you have normal, it doesn't do anything hormonally, it doesn't change any hormonal balance, it doesn't change your testosterone levels that some things do, it doesn't change behavior.
The sex act is the same.
The sex act is completely the same. There's no discernible difference except that when the sperm are deposited into the female, they don't move, like Jochen just said. And no one will ever know that. The only thing that happens is they don't escape the vagina, which means they can't fertilize an egg. So in terms of outward appearance, there's no changes. The other thing is that for cultures where virility is tied to fertility, it's temporary. This would be a method for preventing fertility for the time being. And it's completely reversible. There's no untoward effects. In fact, the next day you're back to normal. You have absolute all fertility. If it's a method that impacts your fertility for a short window of time. My first hope for the immediate future is that pharma embraces this, because funding from the government and funding from MCI is fantastic. It's letting us do all these basic preclinical studies, but to actually go into human beings takes a great deal of money and takes, to be honest, a certain amount of expertise. That developing a drug, how to make a pill, I have no idea. Jochen and I will look at each other with quizzical looks on our face. How do you know how to make a pill? That's not something we do, but to be fair, pharma is really good at that. So we're hoping that our next round of studies, which we haven't published yet, but we're trying to publish now, about the story we've been telling you about the efficacy in mice, and then hopefully even greater efficacy in the next round in rabbits. When we do that, we're hoping that those things, and those are things we're doing with MCI funding and with some NIH funding. But the next steps are not only expensive, but require an expertise that we're basic scientists, we're not drug developers. I'm hoping that pharma embraces this and joins us in this trip, that they see the merits in this and they start helping us and bring it to fruition.
The two of us, we were incredibly lucky in getting fantastic people working in our lab, having fantastic collaborations with chemists who know how to develop compounds, with a person who on a molecular level is able to study how our drug binds atom by atom to our enzyme by a method called crystallography. We really were lucky to attract the right people whenever we needed them. And we will need this luck in the forthcoming years. As Lonny said, we need it. We need the expertise how to make a pill. We need the expertise how to do a clinical trial that it's going in the right direction, and that we do the right statistics, that we deal with challenges we cannot even foresee. Because I said before, we are just climbing one of the big mountains nobody did before, and we have no idea what comes after the next corner. But on the other side, look, Lonny and I had this fantastic story in the last years, and let's hope that we can make it up to Everest.
Who do we think this would be relevant for? And it's certainly for any couple where the man wants to participate in family planning, and for any couple where there's no concern for disease, because a condom certainly protects against disease, is better than the method we're talking about. It's only a contraceptive, it wouldn't protect against disease. But it would be for couples where a condom is too intrusive, and the idea that a man can participate equally or even take over the family planning responsibility, it would be for that couple.
I really think it will be a game changer for men in general. in a way, this sort of contraception could replace the condom. Not totally, because it does not prevent sexually transmitted diseases, but otherwise, it's in a way the same as taking a condom, using a condom.
Without the interruption. And putting on a condom is a lot more intrusive than taking a pill with 30 minutes to an hour before the actual act, as long as you have that window of, and that's going to be a challenge, actually, that people will have to remember that they're on a clock, right? We don't know, Jochen mentioned before that you'll be that our initial plans, our initial sort of mouse studies suggest that 3 to 4 hours would be about a time window when the male would be infertile. But we don't know what our ultimate pill is going to be.
And what we also do not know if the man takes the pill again after 3 hours, whether it will be as protective. Stuff like that has to be shown in future studies.
I'd like to share with the audience the sort of epiphany moment we had, because I can remember it to this day. We were working with these medicinal chemists that were making our inhibitors better for using them in animals. And we hadn't really thought about contraception yet. We were thinking about other uses for trying to figure out what our enzyme is useful for in the animal. And it was right around, it was just before Christmas, 2 years ago, 3 years ago now, just before Christmas in 2019, or 2018, just before Christmas in 2018, during our lab meeting, our postdoc said, I tried this crazy experiment. I injected this inhibitor into a male, and then an hour later, I collected the sperm, and they didn't move.
And what happened was she said that, and
I immediately said, oh my God, you have, this is the gold. I use some term like, this is the holy grail.
You have a
contraceptive.
Paradigm changer.
And then Jochen said, it's better than that. It's temporary. And so right there was the idea. So Jochen and I we have a unique situation where we co-direct a lab. And the reason we can do that is because we both know that we're both needed for almost all good ideas that come to both of us.
He makes them better.
He actually improves the ideas that the nascent form of an idea, or the other way around, that ideas are organic. I said, oh my God, that's a holy grail. And he said, oh my God, it's even better than the holy grail because it's a new paradigm shift. It's an acute, it's rapid, it turns on, you don't have to wait. And that's what started this journey. So it was fortuitous.
You know, and we really have to thankful
applaud our postdoc.
This postdoc who
was a former MCI fellow who was funded, MCI funded her fellowship. As soon as we put these data, as soon as we mentioned these data, this observation, her funding immediately came from MCI, because MCI recognized the power of this. But it was just such a beautiful epiphany moment where it was like sort of all these lights, these light bulbs started going on in our heads almost immediately, one after the other. And it was just an organic idea that blew up.
Yeah. Look, and again, this is an effort of multiple unique people. And it could not have been done, or it could not be done without this collaborative effort. Yeah.
It's not a case where too many cooks spoil the broth. Too many cooks are essential to make this broth.
Many cooks.
Many cooks. That's right. It's not too many. Many cooks are essential to make this broth, right?